Welcome to session 7 of Coding with Doc. There are only going to be 8, so well done for making it this far. Again, as always, if you've not subscribed, do subscribe on that button below. And the aim of what we're going to do today is we've already looked at in those early sessions sequences with a command one after another after another. And then we've looked at selection where it's doing one thing or another. So sequences tends to be commands like print and input, or even import, which we'll come on to. And the selection tends to be commands like if and else, do this or do that. Or you might even have 3, if, elif, else, or 4, if, elif, elif, else. These last couple of lessons are all about iteration, about loops, so it's going round. And there are these 2 types of loops. There's a for loop, where we know exactly how many times it's going around. So we go around it 4 times, 5 times, 4 x in range, a set number of times, what we might call a count-controlled loop or a definite loop. And then we've also got an indefinite loop, where we're doing it until something happens. So you keep checking until this is the case. You keep doing it until this is the case. Now, that type of loop, there's different structures for that in different programming languages, but in Python, it's always called a while loop. Now, in this 7th session of Coding with Doc, what I'm aiming to do is to look at these 2 types of loop. So we've referred to them in previous sessions as a for loop and a while loop. But in this session, what I'm hoping to do is really look at the second of those. The last session, session 6, was looking at the for loop. This is the 7th session. I'm intending to look at the while loop, which is the most complicated of the loops. Again, I'm going to be following a prim methodology. So the idea behind prim is we'll begin with doing some predict exercises. And on those predict exercises, you're not copying them down. All you're doing is simply looking at the code as it appears, thinking about code, and coming up with a guess, a hypothesis, a suggestion about what will happen. We'll then do a couple where we'll run them and we'll do some answers and we'll investigate slightly. Then a bit of modifying and making. Now, the modifying and making on this session are going to be linked together a little bit more. So we'll do kind of 3 tasks in a kind of a RAG type rated 3 tasks where you can pick which one you do, and then I'll run through all 3, and then pick which one you do and we'll run through all 3. The first set are much more modify, the second set are much more make, but you might feel they both make. We'll see when we get there. Now, the predict one. So here on this first one, if I run that bit of code, this is really recapping what we did last time round, what's it going to do? And hopefully what you've suggested is something like that. The print for loop challenge, I'll put that at the top. And then it's going around 3 times for I in range 3. So it goes around 3 times. And it starts with the number 0, as it always does. And then it goes to 1, and then it goes to 2, and it gets up to that 3rd number. And then it says the for loop's finished. So that was hopefully relatively straightforward. So now let me show you another bit of code, and this time it's more of a while loop. So we've not seen one of these before. So just look at the code, try and think what it does, try and write down an answer. So in terms of the output, it's identical. It creates exactly the same thing. It does while loop challenge, and then it will go count is 0, while the count is less than 3, counting with a while loop, and it'll print 0, counting with a while loop, and it'll print 1, counting with a while loop, and it'll print 2, and then it'll stop because it'll have reached 3, and it'll come out. I've cheated slightly because I put the same picture in as the for loop, but they would be identical, except it'll say while instead of for in there. Now, okay, so that's given us some predict examples to work with. Now I want to move to the first of our kind of run exercises. And on these run exercises, what I want to think about is how would we do various tasks using a loop. So there are two tasks there. One is, can we print the names of the first 5 planets? And the second one is, can we make it so that we ask a user for a password and it keeps asking them for the password until they get it right? Now, one of those naturally lends itself to a for loop, and one naturally lends itself to a while loop. So just think about that for a second. Which one of those is a for loop and which one of those is a while loop? Which one of those just does it for a set number of times, and which one of those does it until something's the case? And hopefully you've recognized that on that first one, the planets will be a for loop, but the second one, in terms of the password, is going to be a while loop. So let's look at those two ideas and let's do those. And let's just re-emphasize those two types of loop. A for loop repeats for a certain number of times. It's what we call a definite loop. And a while loop keeps going for as many times as it needs to do until it meets a certain condition. So what's called an indefinite loop. So let's do that run exercise. So the first thing I want to do on this run exercise is to create a list of the planets themselves. So to do that, you'd go planets equals. Now, up till now, when we've done a variable, we tended to just do a single variable on its own. So you do something like Mercury. What I want to do now is introduce a slight little new idea. And that's the use of these square brackets. Now, they're above the enter key on the keyboard. I don't want you using the round brackets above 9 or the swervy-worvy brackets that are also above the enter key. I want you using the ones that look like the square brackets, the ones that are on the bottom of the key. So you've got Mercury, we've got Venus. And what the square brackets are doing, obviously, is allowing me to put in multiple things into one name. So planets is going to be each of those things, not just one of those things. So I've got Mercury, Venus, Earth, Mars. Then we've got Jupiter. Then we've got Saturn. Then we've got Uranus. And then finally, we've got Neptune. And the scientists at school tell me that Pluto no longer classes as a planet, which feels all wrong from my childhood, where I'd learned that that was the last of the planets, but apparently it's not anymore. So we've got that, and we now do print, and we go, the first 5 planets are. Now, in order to get the first one in there, I could just do this. I could go print planets, square brackets, 1, or 0, the first one, 0. And then print planets, square brackets, 1. Now, if I run that, what that will do is give me then Mercury on the first line and Venus on the second line. So doing that. And obviously I could keep going down and go print planets 2 is, and then run that, and it'll give you Earth as well, and 3 and 4 and 5. And so, of course, this lends itself, as we'd said before, to a for loop. So if I do now for, we need a variable name, so we can call it whatever we like. Let's call it I. For I in range. Now, if we want to go up to 5 planets, we'll have to put a 6 in. So there, that'll do that. And now, how will I change it? So I'll take out those two. How do I change this? I say, instead of printing an actual number, 0, we change it to the I, because the I is going to change each time it goes around the loop. And so it'll do 0, and then it'll do planets 1, and then planets 2, and then planets 3, and 4, and 5 as it goes around the loop. And now when I run that, it gives me Mercury, Venus, Earth, Mars, Jupiter, Saturn. It's given me actually 6 planets. So if I change that to 5 and run it, it will now give me 5 planets. I miscounted that. So that will give me the names of the first 5 planets. Now, the second question that you were confronted with was, could we write a bit of code that will allow a user to keep going until he gets a password correct? But I'll let you just get that bit of code we've just done there down and made before we do anything else. The second task we were asked to do was one that kept asking a user for the password until they got it right. So we could do a simple thing where we go password equals, and then we invent the name of the password. So you could say password equals Labrador1. Simple password. And then we have our password system. Print welcome to Docs not very secure password system. Now on this one, we've done something not dissimilar to this before, where we did one where we simply put in a thing like a guess, and we put guess equals an input where we said, please enter the password. And then we did if guess is the same as password, print correct. And then we did an else to that. I think this was in session 3, might be wrong, might be in session 4. And then we put in incorrect if it's wrong. Now that kind of works. So if I did that and I put in doc and then press return, it said incorrect. But if I ran it and I put in Labrador1, put it in the right place, Labrador1, it then says correct. The problem was neither of them stopped you then going into the main program. So if the main program was here, yeah, and we just had a print that said you are now in the main program, both of those would let you into the main program. It wasn't stopping you, was the fact you got it wrong. So let me just illustrate the fact that getting it wrong is not stopping you. So if I put in Joe there and press return, it said incorrect, but it still let me, you're now in the main program. So we wanted to stop that. Now, the only way to stop that really is with a while loop. So at the top of a while loop, you could create a variable which you call past. I was going to call it correct then. Yeah, so past equals true. So it's a straightforward true or false variable. And then you do here while past. In fact, let's change past from being true to being false to begin with. So we say while past is the same as false, then now we've got to put all this into this loop. And we've got to keep all the indents right. So we need those indents for the if inside the loop, and that indent for the else inside the loop, and all that indented so that it's inside the loop in the first place. Without that, it wouldn't do that bit inside the loop. The main program still stays as a main program. So while past is false, please enter. Now, the only thing we need to do to stop that being able to change is here, we need to say past equals true. So if they get it correct, it changes past to true and then lets them out. So let me demonstrate. So now that's a lot better in terms of a password system. It says, please enter a password, and I put in Churchill, and it says, no, that's wrong. And then it goes back around the loop again. Please enter a password, and I put in Joe again. No, that's incorrect. Please enter a password. But when I put in Labrador 1, it then goes correct, in the main program. So the while loop will keep going round that circle as many times as it needs to until I put in the correct password. And only when I put in the correct password will it let me out of that particular loop. Now, there is a problem with while loops, and that's what we're going to look at in the run exercise. We're going to do now a run example. So on these run examples in these later sessions, session 7 as we are now, what we're going to do is you're copying the code and you're observing how does the code work. And that practice with code then will help you on the modify. So on this one, what I want to do is a final kind of run exercise, or you could say it's the first of the investigate exercises, but I want you to code this with me. So I want to do while true. Now, you could, if it makes you more comfortable, create a variable and you say x is true, and then you go while x is the same as true. That's fine. And then you do this kind of thing where you go print help, I am stuck. Now, if I run that, this is a common logical error that people make when they use these while loops. They forget to create a condition for getting out. Now, you can see there on the side of the screen, it's still running. It's been running, and it's running all the time I'm talking, and it's ultimately it'll crash the computer as it sits there running in almost infinity, running at the speed of the computer, going, help, I'm stuck, help, I'm stuck, help, I'm stuck. There's no way for it to exit the loop. So I'll give you a second if you want to make that one, But then I'm going to give you another bit of code, and I want you to investigate what's happening with this code, why is it happening, and can we stop it happening? So let's then look at that second bit of code. I'm going to delete that now. If you wanted to go back, just pause at this point so you can make that piece of code. Good. And then, so we'll take it out. And so I'm going to now build a second piece of code that's got, as I say, some deliberate mistakes in it. It'll all run, so it's not errors in typing. It'll run, but an error in logic. And I want you to think, where's the problem? So we've got your hero stands surrounded by a huge army of the barbaric horde. Then print your hero pulls his sword for what must be his final battle. You can see I'm probably spending too long trying to invent stories and failing miserably. So then we create some sort of health variable, and we'll say that health is 10. And we'll say that to begin with, we've got barbarians set to none. We haven't killed any barbarians at this point in time. And then we've got damage equaling 3. In effect, what we're doing in terms of a hit is 3 each time we get hit. So while health exclamation mark equals is not equal to. So equals, it does equal it. Exclamation mark equals, it's not equal to it. While health is not equal to 0, what we want to do is increase the number of barbarians we've managed to kill. So barbarians is barbarians plus 1. Great. Nice, easy logic. Then we're saying that health is counting down to 0. And so what we're going to say is health equals health minus damage. So you're taking away damage so that he's getting hit each time, but he's killing a barbarian. He's getting hit, but he's killing a barbarian. Then we'll do a print statement so the user can see what's going on. And we'll print a statement that says the hero swings his sword and takes out a barbarian. That's the one that we just did on line 9. Yeah, so it takes out a barbarian. So the count of the barbarians. But takes, and then let's put it in, but takes damage, 3 damage points. Now, he's clearly going to hopefully perish. Not a very good game. And then we put your hero fought bravely. He took out barbarians. So the number 10, 20 barbarians. So it's gone through and it's done that. And then we go print. Alas, poor Yorick. Yes, no, so alas, your hero now lies dead. So he's just going to die. We've not built anything that's going to do otherwise. So you're expecting it to go hit, 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 dead. Now, when we run it, we've got a problem on our hands. Keeping telling us he's fighting still. So he's took out a lot of barbarians by this point. So if we stop that, we could even add some code that said, takes out a barbarian, print, you have now taken out barbarian number of barbarians. So now if we run that, it doesn't like that. Let me just have a look. Why is it not liking that? Because this variable is called barbarian, not barbarians. So if I run that, you can see we are doing very well. We are taking out lots of barbarians. But you can also see it's still going. Why? Why is it happening? How can I stop it happening? What's going wrong? Pause it at this point, have a play, have an investigate. I'll explain in a moment. So, welcome back. Now, the trick here is you've got to look at this health variable. It started on 10. And what happened to it? It had 3 taken off. So 10 take away 3, 7. Take away another 3, 4. Take away another 3, 1. Take away another 3, minus 2. And we said while health is not the same as 0. Easy mistake to make in a while loop. What you want it to say is while health is greater than 0. And now when you run that, it runs exactly as you expected. Because that's what we meant. But it's very easy when we're making code to make those exact types of errors. Now, having done that, what I now want to do with you is to look at some new challenges. On this modify example, what I want you doing is thinking through on both of these, how does it work? Because that'll help you with the making that we're about to do. So the first of these modify make type exercises is this one. So you've got a choice of which one you do, and I want you to pause the video after you've picked, because otherwise it'll just run on into me talking about the answer. And on the red one, you're going to start with a total of 0. And then you're going to ask the user for a number, and then you're going to say, so they say put in 2, and you'll say the total's now 2. Then you ask them for another number, and they'll put in, say, 3, and you'll say the total's 5. So it'll be 2 plus 3. So in effect, the number you keep adding keeps getting added to the total, and then when the loop gets to 50, it stops. So it's not, it has 10 numbers or it has 20 numbers, a for loop. It's a while loop. It's while the total is less than 50, keep asking them for a new number. So that's the first choice. The amber one is to ask them for a number and then ask them for another number and then get the program to add those two numbers together. And then ask them if they want to enter another number, and if they put in a Y, a yes, ask them if they want to enter another number, and it keeps asking them another number, asking another number, until they choose to say no, and then at that point, you tell them a total. So the test's not, is it over 50? The test is, have they stopped saying yes? And as soon as they've stopped saying yes, then it gives you the total. And then the green task, ask for the name of somebody they want to invite to a party. And then after they've given that name, it says, Harriet's now been invited, or Jamie's now been invited. And it adds 1 to the party count. And then ask them if they want to invite somebody else. And then you keep repeating that loop until either they say they don't want to add any more people to the party. And then at that point, it's gone through and it's told you how many people have been added, and so-and-so's now been added, so-and-so's now been added, so-and-so's now been added. So it's gone through that list of people. Now, as I say, pause the video at this point because we're about to give you a chance to get that done. Working through those answers. Now, I'll start with that red challenge. So that red challenge suggests that at the beginning, the total is 0. To do that, you just go total is 0. And then we've got to keep doing it until the total reaches 50. So while total is less than 50, and then it's going to indent. So this is what we're doing while it's indented. And then we can say number is, now we've got to tell it it's an integer input because otherwise it'll treat it like it's a word and the thing won't work. And it says enter a number. And that'll give them a chance to type in a number. Now, of course, you could have done that if you preferred to do number equals int number like that and not have the integer there. Both of those work in exactly the same way, but some of you, I suspect, are now getting more used to the idea of putting the int with it. I'm not bothered which way you do it. I think both are equally valid. You do it the way that makes more sense to you. So now we do total equals total plus the number. And we could do print the running total is total. And now at the end of the program, which is always going to get to, outside the loop, we do a print the final total was total. If I run that, it says enter a number. And if I start with 56, it's going to boot me out of the loop before I've even got round. The running total's 56, final total's 56, you're out. You went over 50 on first shot. Whereas if I play a bit more of a cautious game and I go 13, then 12, and then 14, and then 16, that finally throws me out. So you can see it's adding up as it's going along. But that gives me that first red answer. Now, let's look at how we can tweak that to do that second challenge, that amber one. So you'll remember the amber one was just ask them, do they want to keep adding as they do the numbers as it goes along. This amber one. So we start with total being 0. And having set the total to being 0, we want a variable which we're going to say choice. And we're going to set the choice to being, yes, we want to add another pair of numbers. And at that point, I'm going to say while choice is, yes, we want to add some more numbers, we need to do a set of instructions. Now, you always need the colons and then your for loops and your while loops. I haven't necessarily pointed that out up till now. So then we go num1, or number 1, let's call it number 1. Number 1 is an integer input. Please enter a number. Number 2 is another integer input. So another number that we're taking in. Please enter another number. Then we're going to add those to the total. So total equals number 1 plus number 2, no space. Variables can't cope with spaces in them. So if you put spaces in them, it will go wrong. So we've got number is total number 1 plus number 2. And then we've got a print that maybe gives us that running total idea again. So running total is, and then comma total. So it keeps us up to date with what the total is. And then a choice to get out of the loop. Choice is an input. Do you want to add further numbers? Y/n, and then a space. I always tend to put a space after a colon there so that somebody doesn't put a space and n and then fails it because they put space n. Yeah, now it'll keep going if they've put y down as their choice. So then we run that and it says there's a problem there while choice is y, because it should of course be double equals while choice is the same as y. And it says enter a number and I put in 12, enter another number and I put in 13. It says it's running total is 25. Do you want to add some more? Yes. Put in another 12, put in another 13. My running total is now 25 again. And you can see it's going round and round and round and it's keeping adding numbers up. And then I put in an n. I don't want to add any more and it stops. So that's the end of the amber exercise. And that takes us sniftily on to that green exercise, which was people going to a party. So on this one, we want to put in choice again, and we'll keep choice as being yes. So we'll keep that variable. We'll have count for the number of people at the party. So this time round, count, a bit like total, will begin on 0. And while choice is the same as yes, so exactly the same as last time round, we put name, if I could spell, name is an input, where it says what is the person's name that you wish to invite. So they can type that in, and then it goes print name has been invited to the party. And then count equals count plus 1. So just on the previous one, if you'd wanted to keep those totals adding up so that the next 25 and 12 and 13 added on to the previous 25, you'd have had to have total equals total plus number 1 plus number 2. When we just had total is number 1 plus number 2, it's zeroed each time round we went round. So you'd have to have total equals total plus number 1 plus number 2. So you'd add it in the same way that we've got count is count plus 1. Now, in just the same style as last time round, you go choice equals an input. Do you want to invite anyone else? yes/no, colon, space, as I say, always do that. And at this point, rather than have the running total, I would have the print at the bottom here that says, you have invited, and then what do we call it, count people to your party. So if I run that, it goes, what's the person's name they wish to invite? And I go, Susie. And then Susie's been invited to the party. Oh, it's not caught with count because up there I misspelled count. Let's try that again. So, probably because I'd accidentally typed on it or something like that. So Susie. So Susie's invited to the party. Do you want to invite somebody else? Yes. Who do I wish to invite? Andrew. Andrew's been invited. Do I want to invite? Yes. Who else do I wish to invite? Rob. Yes. Who else do I wish to invite? Fran. Yes. Who else do I wish to invite? Ben. No, that's it now. We've got a nice party going. I've invited 5 people to my party. So you can see that's running around those options, doing that particular exercise. Now, at this point, we're going to move to doing another modify make kind of piece of work. And then we'll have 3 more challenges, and that'll take us up to the end of this session. So this is the modify challenge. Now on the modify challenge, what I'm wanting you to do is look back at the code that we did for the secret game code, and can you tweak it? Can you tweak it that it says too short if the guess is less than 6 characters, or too long if it's more than 6 characters, or incorrect if it is 6 characters but it's wrong. And then it stops it after 5 tries. Now you can see that while I'm doing a kind of a modify the secret code, it's almost like you're guessing the code. In reality, this is the sort of code that's behind most password systems at a very basic level. So I'm just trying to get you to grapple with that and solve that, and I'll run through the answer in a moment or two. On this second modify example, I want you to make it with me. And if you need to pause as we go through, feel free, pause away. So we'll start with a secret word. And we can pick whatever we want. And I'm just going to call it Python because we're programming in Python. But you can pick whatever you like as a secret word. It could be a football team. It could be a place in the world, a secret word. And then I'm going to say a guess that somebody makes is blank at this point in time. It's just quote, quote. And then I'm going to put in a test. While guess is not the same as word, guess equals an input. Can you guess my secret word? So now it's just going round and round and round, and that one is saying, I don't recognize what word is there, so it needs to be secret word. Can you guess my secret word? Quote, and then a space, because it stops, again, somebody adding it in. And print, now print, you guessed it. So I want you to make that code with me, and then I want you to modify it to do some specific modifications. But pause me at this point before we run it, before we do anything else, just so you can check it through. Welcome back. So when I run that, it goes, can you guess my secret word? And I put in Liverpool. And it says nothing. Just says, can you guess my secret word? And I put in wolf. Again, nothing, no feedback, no interaction. And then I put in Python, and it goes, you guessed it. So it kind of works, but it's not very friendly as a game or a guess. Now, ultimately, we could have a list of words here. It's Wordle, in effect, isn't it? Where it's like guessing the letters of a word. Yeah, but that's a whole step up. But you could have a list of words, like we had a list of the planets, and then it could randomly pick a word out of that sequence. So it made it different each time. But what would be good here is if we could modify the code so it does two things. First of all, it tells us we've got it wrong if we've got it wrong. And then at the end, when it says you guessed it, it tells me how many guesses I had. Now, pause me again at this point and see if you can add those two features. First of all, something that tells me I got it wrong. Second of all, something that tells me how many goes I had in total when I finish. So again, welcome back. Now, in order to do the wrong one, let's do that bit first, and then let's worry about the totals in a second. So we say if guess is not the same as secret word. So if that's not the same, inside that we want it then to say, so indented in, inside that we want it to say, that was not my secret word. Maybe even wrong. That was not my secret word. So it's given you a chance, in effect, to check your guess against the word, and now it's giving you that you got it wrong. Now, obviously, everything else we do here doesn't want to be in that loop, but we probably still might want things in the while loop, and we're still going to want things down the end. Now, the second thing I asked you to do was how many guesses did it take? So we need some new variable then that's going to count the number of guesses. And so it's going to begin on 1. No, it's not. It's going to begin on 0. And then when it gets to the end, it's going to print you took count 6, 3, 5, whatever the number is, count guesses. You took 3 guesses. You took 6 guesses. Now, how can we make it add? Now, if I put it in there, it'll only add it if it's wrong. If I put it there at the end, but not in the indent, in the while loop, but not in the if indent, it's going to be able to then see count is count plus 1. So it can see that I've added 1 to the count. Now, as I run that, it says, can you guess my secret word? And we'll do roughly what we did last time round. And I'll put in wolf. And it says, wrong, that's not my secret word. Can you guess my secret word? And I say, Everton. And it says, that's not my secret word. Can you guess my secret word? And I put in Python. You guessed it. It took 3 guesses. So there you can see it's worked out this next one. Now, that's me working through a modify example with you that was a bit of a modify and a make example. I'm now going to go to one final make challenge. Welcome. Now we're going to do a make example. So these make examples I always think are the most fun. These are the bits where you're trying to do the code yourself. So I'm giving you here another make example to do. So the last challenge of this exercise is this make challenge. And you can pick which one you do. The red and amber are pretty similar, but amber's going to require you to look something up online and to try and search out how to do something. Of course, I'm going to work through the answer with you in a few moments, and you'll be able to check that anyway by just letting the video play on. So let's just go through what the 3 challenges are. There's the red one. Can you write a program that starts and says 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then says left off? Can you alter that for the amber one so that it says 1, wait a second, 2, wait a second, 3, waits a second, 4, waits a second, until it gets to lift off. So you've got that kind of slightly more paced thing where it's not just gone all the numbers and lift off down the bottom and all in one go on the page. It's pausing as it's doing it. And then the last one, ask which direction the user wants to count. Are they counting up or are they counting down? Ask them for a top number and then count from 1 to that number. So if they say they want to count up, then it's going 1 and you'll count to whatever number that. So if they said, say 15, it goes 1, 2, 3, 4, all the way up to 15. Alternatively, if they say down, it does the opposite. It starts at the number they specify, say 20, and then it goes 20, 19, 18, 17, 16, 15, 14, 13, and down to it. But then, crucially, can you also give a third option, which if they don't say up or down, says I don't understand, and doesn't stop the program, keeps the program going round. Now, those are requiring while loops. The green one is requiring a while loop and an if statement and a sequence. It's a good, confident thing to be doing at this stage in the series. The red and the amber are really testing your understanding of loops. And the amber's testing, can you look up how to introduce a function, an external function? And I've told you it uses a command called time.sleep. But at this point, pause the video and let's get those questions done. Running through those final ones. So the first one asked you to write a program that will print a number from 1 to 10 and then say lift off. So we can put a kind of a basic print statement in. It's not necessary, but you can put a basic print statement in that says a countdown from 10 to 1 or 1 to 10. It probably would be better to go 10, 9, 8, 7, 6 and then lift off rather than 1, 2, 3, 4, 5, 7, 8, 9, 10 lift off. It's slightly more complicated to do a count down rather than a count up, but ostensibly it's the same thing. So you get a number that is starting at 10. If you're doing it the other way around, you'd have the number starting at 0. While the number is not the same as 0, it is going to be 0 at some point. So you can do not the same as 0. If you're doing it the other way around, you do it the other way around. You print the number. And then inside the loop as well, you also do the number is the number, take away 1. So the first time it's 10 take away 1, 9 take away 1, 8 take away 1, 7 take away 1, 6 take away 1. So always the number is the number, take away another 1. So that'll just count down. Now, likewise, if you're doing it the other way around, you'd have swapped your 1, 10 and your 0 around, and you'd have add 1. Yeah, but it's the same. It's the same thing. And then after that, separate to the loop, outside the loop, back at the main margin, you'd then have your lift off. If you put your lift off inside the loop, you'd have it after every letter, after every number, and that kind of would defeat the purpose. So if I run that now, you'll see that that does 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, lift off. Equally, just illustrating if that was indented, the effect of that, obviously it puts it after each one because it's wrapped inside the loop. So I'll take it out. And just in case you wanted it the other way around, you change your number to 0. You'd say, well, it's not the same as 10. And here, instead of taking away, you'd add. And then that would go 1, 2, 3, 4, 5, 6, 7, 8, 9, lift off. Yeah, if you wanted to get the 10 in, you'd obviously whack in an 11 there. Lift off. So all fairly straightforward for that first one. I'm going to change it back to where I went to begin with. I'm going to change it back to starting at 10, going down to 0, and then taking away 1. Simply because I think it looks better. I think it looks more like a rocket launch type feel to it. So that's that first one done. Now, the second one asked you to do something rather different. It asked you to look up, using the web, the idea of how do you get pauses in. Now, computer languages can often bring in commands from what's called libraries, commands that sit outside the language. Now, there are three kind of big ones that you need to know for Key Stage 3, and you need to know for A level, and you need to know for GCSE. One of those is time, another one of those is a thing called logo, and a third one of those is a thing called random. So those are kind of the big obvious three that you often get asked to import into Python. Now, this one, obviously, because it's pausing, it's the middle one of those. It's not logo, it's not randomness, but we need to import it. Now, if you're importing randomness, you just go import random. If you're importing the ability to do pi, you'd import math. It rather offends me, it's not maths, but we have to bow to the American misspelling there on that one. This one unusually follows a slightly different structure. It goes from time, import sleep. So that's a specific command within a module called the time module. And what that then does is allows a command called sleep to work. So then you can just go sleep for 1 second, or 2 seconds, or 3, or however many you wanted. When you run that now, it goes 10, 9, 8, 7, and you see that kind of countdown process happening, and it feels a lot more kind of real in that sense. So a useful little command. It required you looking it up. It was not something we've covered up till now, but I thought it was an interesting one in terms of developing that particular idea. Now then, the final one, the green one. So this is the one where we had three choices. Did we want to count down? Did we want to count up? Or have we made a nonsense choice? So to start with there, I'd have something that we'll call it direction. And we'll make that an input, and we say, do you want to count up or down? Press U or D. I'm leaving that space just in case that confuses people. Now, we could capitalize whatever they've typed in and make it so it's always going to work, whatever the capitals are. But I'm just going to stick to simplicity here and have it, if they've typed a lowercase u, then they get it counting up. If they've done a lowercase d, it goes down. Otherwise, it says, I don't understand. So, we need an if statement. So if the direction is the same as u, so they want to go up, then we need to do the commands for up. I haven't put them in yet. I'm going to leave that there, but we will put them in a second. And then we want elif, otherwise if, direction is the same as down. If that's the case, we then want the commands for down. And then finally, else, if all that's not the case, now you notice how each time you never end up with your elifs going diagonally, because what that's doing is making the command sit within the previous command. Now, if this one happened, I think it was dead simple what it wanted. It simply wanted you to say, I don't understand that option. Yeah, so that if you put something other than a U and a D in, you got that. So then we're on this next one. What do we do when we want it to count up? Well, there we wanted a number. And on that number, we wanted it obviously to be a number. So we'll make it an integer input. Now, obviously, we could put that in two separate lines, like we did on the previous one, and say, what number should I count to? So it's counting upwards. And then you do for, let's a variable name, x, can pick anything we like, for x in range 1 to number. Now, you might have to do number plus 1 because it's going to count to that number, but not include that number. Whereas if you do number plus 1, it'll be whatever the number is, add 1, so it'll also include the number. So if it counts to 20, it won't stop at 19, it'll get all the way to 20 by telling it to count to 21. It'll include 20 as a result. So you've created that for loop. So count from 1 to whatever we've chosen plus the number, and then we do print x. So it prints that. Now, likewise, if you're counting down, you want something similar again. So number 2 is you could have called it number, yeah, but number 2 is an integer number. What number should I count down from? And so there you've got a second option. What number do I count down from? And this time round, just like before, you're doing for, let's have a different variable name just for the keep it mixed up. So for y in range. Now this time round, we want to go from the number. Let me just, I think I've done this wrong there. I'm just re-looking back at the challenge. It counts down from 20 to that number. What number should I count down to from 20? Now that's a slightly different thing. It was just occurring to me. I was trying to work out what I was being asked to do. So for y in range, now it's going to go here. I was going to go from number 2, but it's not. It's from 20. And where do we want to go to? We want to go to number 2. Now you could make it include number 2 by taking 1 off it again for obvious reasons. And we also do a -1 to say it's counting down. It's counting down to it. And what do we want it to do inside the loop? We want it to print y. Now if I run that, you should have an answer to the green one. So when I run that, it says, do I want to count up or down? If I say, let's practice all 3. So I'll go, we want to count up. What number should I count up to? 35. And then it goes from 1 to 35. So that's working. Run it again. We want to count down. What number should I count to from 20 from? Slight mistake in my print statement there. What should I count down to from 20? Let's take out that second from just in the program itself. It won't fix it now as it's running. So we'll tell it to count down to 13. So there it should go 20 all the way to 13. If I not put that -1 in, it stopped at 14. And then I felt it was right, but I've just, by adding the +1 and the -1, I've made it included that number, and it just feels a slightly better solution as a result. And then finally, I run it and I say, what do I want to count down to? And I pick an option that's not an option. I pick the option of X. Yeah. And what does it do? It says, I don't understand that option. So there I can see that all 3 of those options are working. I've coded them all exactly as the challenge required. And that brings us to the end of the challenges in this particular session.